So in this video, let's look at the disjunctions, or the compound inequalities that are joined with the word or. And again, it's a combination of numbers in both sets, or the union. So remember, unions like, say, a marriage where a man and a woman are joined together into one family. And that's what's going to happen here. We're going to take these two sets and we're going to join them together in a single answer. So I have that x is less than 3. So I'm going to draw that. I have x is greater than 0, open dot, and then to the right. And now what I'm going to do is I'm going to combine. So in this bottom line here, which is going to represent my answer, I'm going to talk about all the ones in the top set plus all the ones in the bottom set. So you can see that it starts over here on the left. And all these numbers are in at least one of these sets. So on this has to be in at least one of them. The 0 itself is in the top set, so it's going to go across all the way to this end. So when I do x is less than 3 or x is greater than 0, I actually have every number in the whole number line in there. So we'd say that this is all real numbers, which can be written as that capital R. All right, so then let's look at B. I have x is greater than 2. So here's greater than 2. I have x is less than 2, which looks like this. Then we'll talk about it again for it's got the word or here. So I'm going to take every number that's represented in these two sets. So starting here, all of these numbers are there. And then I get to the 2. The 2 itself is in neither one of them. So I'll put an open dot there. And then to the side of it, there are all these numbers to the right of the 2 are included. So when I draw my answer, it looks like this, with almost the whole number line except for there's a hole at 2. So we can represent that in an answer shortcut just by saying that x does not equal 2. And that means it equals everything else. All right, so C. We have x is less than negative 3. So here we have the x is greater than 2 here. And again, we have the or, so we want to show what this is my problem, and I want to show what the answer looks like down here. So all the numbers here are represented up to the 3, and it's not, because it's a big old circle. None of the numbers here in the middle are represented, and then we pick back up a circle on 2, but everything else to the right is represented. So we have these two separate sections. Whenever we have a separate section, we write it's going to look just like this. It's going to look like, for this, x is less than negative 3. When there's a break in the graph, we write the word or. So these numbers or these numbers, x is greater than 2. So for this particular problem, the answer comes out just like the problem itself. One last inequality here for a compound inequality. I have x is less than 4. That should be an open dot. I have x is less than 1 here. And it's an or. So as long as it's in one or the other, it's going to be there. So here, this is in both of them, but that's okay. It can be in both of them. So all of these, when I get to the 1, it's covered in the top one, so I go over it. And these are up here, so these are all there. And then this was an open dot right there. And then nothing. There's nothing to add into it right there. So with my or, I get an answer that looks like this, which would be x is less than 4 for my answer. All right, so now what I want you to do is I want you to pull up the next page, and those are going to be try me problems. So here they are. So you want to be aware of the fact that some of them are going to say or, and some of them are going to say and. So the and are the ones that the solution is the place, or the numbers where they're in both sets, and the or adds both two sets together into a single answer right there. So you can stop the video now, but I am going to continue. I have one more problem at the very end I'm going to do, but I want you to do all 10 of these inequalities. You can whip them out pretty fast. So I want you to do that. So stop or take a look at the last problem and then come back and work these. So and statements can be written as a three-part inequality. So for example, this one means -7 is less than or equal to 3x minus 1, and 3x minus 1 is less than 11. So it's combined into just the one three-part. And you know why? Because when you think about the answer to a lot of the ands, it looked like a three-part inequality. To solve these, you can do it pretty quickly. Just going from here. So I'm going to look at the middle, and the goal in the middle is going to be to undo it till I get an x in the middle. So the first thing I need to do is to add 1. And when I add 1, I've got to add 1 to all 3 sections. And that's going to give me -6 is less than or equal to 3x is less than 12. Now I'm going to need to come back, and to finish up there, I need to divide, to get an x, I'm going to have to divide by 3 there. So I'm going to have to divide all 3 parts by the same thing, and I get -2 is less than or equal to x is less than 4. And that's going to be my answer. And if I wrote it on a number line, I'd have a -2, I'd have a 4, closed in dot, open dot, and the x's are what's in between those two numbers right there. So we will, I'll just talk about this really quick. So I would start this one by multiplying through by the common denominator of 12. And that's going to give me 5 is less than a -2x plus the 4 going to 12. 3 times 3 times 3 is 9. And then 12 going to 12 once, that's an 11. So I come up with this. I would subtract 9 from all 3 sections and get -4 is less than -2x is less than, 11 minus 9 is 2. Then I'm going to divide everything by -2. What happens when I divide by a negative and I've got inequalities involved? It is going to flip the inequality. So I get 2 is greater than x is greater than -1. When I draw it on my number line, I'm going to put the -1 first because it's smaller, and the 2 second, open dots, and everything in between right there. All right, so I'm going to stop this video now. Don't forget to do those try me problems.